So the lesson we're doing today, we are revisiting something we talked about first semester, and we are going to be getting back into circles. And I'll explain why we're going to go back into them here in a second. But, you know, with this year being how it is, and we've taken out a lot of things from this school year, the other half of this chapter, aside from rational functions and asymptotes and holes and all that stuff, is a whole study of what are called conic sections. And after we do all that stuff, typically we would get back into parabolas, circles, things that are called ellipses, which are ovals, and graphs that are called hyperbolas, which kind of are made up of two separate branches like this. Well, this year we are taking out ellipses and hyperbolas, and we're actually just going to focus on parabolas and circles. That's all we have left for this, the rest of this chapter here. And so today is all about circles. And one of the things that comes back in this section, the whole reason why we're kind of keeping this in, is the idea of completing the square. Now, completing the square is something we talked about first semester, and I'm going to refresh your memories on it. But first and foremost, to remind you guys of the general equation of a circle, which came up on our systems test, is this. It's x minus h squared plus y minus k squared equals r squared. And so we talked about this first semester. We had to graph some circles on the system stuff. But on the system stuff, I didn't really have h's or k's in there. Our origin was always the center. But in this equation, h comma k is the center. And remember that r is the radius. So this is what we talked about first semester. And put that in perspective, if I had some equation that looked like this, and I said, what's the center and what's the radius? The center is -1, +3. It's always the opposite of the things inside the parentheses. And the radius would be the square root of this, which is 3. Again, these are all things we talked about, but I'm just trying to refresh your memories on what we've learned about circles already. The new stuff is, okay, if I give you an equation, I want you guys to look at this. If I give you an equation like this, well, first, I want us to be able to identify that this is going to be a circle. And in a normal year, this would be a big focus because we would normally be talking about 4 different types of graphs. And the big idea would be, what type of graph does the equation form? Well, since we're only talking about circles, if you guys ever have x and y being squared like this, and they're being added, like there's a plus sign, this is going to form a circle. Now, we need to get our circle equation to look like this equation here. So the whole reason I'm doing this lesson, and I wanted to keep this in, is to work on transforming equations into how they need to look, okay? So I want to take you back to first semester when we solved quadratics, okay? And when we solved quadratic equations, you don't need to write this if you don't want to. When we solved quadratic equations, we had a lot of different options. We had factoring, if it factored. We had quadratic formula that always worked. You could solve by square roots if there was just an x squared in it. But then we had this kind of random method, and it was called completing the square. Completing the square. And at the time when we did it, I made a comment that this method is probably the least used method in solving quadratics. Like, if you get to choose, you probably wouldn't choose this method. But this idea of completing the square, the whole point of it, is what transforms an equation and gets you to have these quantities being squared. That's what completing the square does. So we're actually going to have to use the idea of completing the square on these problems not once, but twice. Because I need to get this x group to be this quantity squared here, and I need to get this y group to be this quantity squared here. So we're actually going to have to do completing the square twice. And to refresh your memories, here's how completing the square works. This is the process where we want to create our own c-value. Like, the c-value that the problem gives us is not good. We don't want to use this c-value here. We want to kick it over to the other side. And we want to create our own c-value. And the way we create our own C value, our good C value, if you remember, we take half of the B value. So I call that B over 2. Take half of the B value, and we square that number. This is how we get our new C value. We take half of the B value and square it. So half of 8 is 4. 4 squared is 16. So we add 16 to the left side. Remember, to keep an equation balanced, you can't just randomly or magically add a number to the left side. You also have to do it to the right side. Whatever you do to the left side, you have to do to the right side as well. And the whole reason we create this good C value this way, the whole reason this is a thing, is because once you create the C value, now we factor the left side. We factor this entire quadratic. We find what multiplies to 16 and adds up to 8. And that's 4 and 4. So if I factor this, it would be x plus 4, but we write it as x plus 4 squared. So we were able to get our x group here to transform into this quantity squared, which is going to be the whole point of what we're doing with the circles. And on the right side, we would get 10. I'm not going to keep going. From here, we would square root and solve, but that's not the point of today's lesson. The point of today's lesson is how do we get from the first part of that equation to make it look like a quantity squared. That's the whole idea, okay? So I'm going to jump back to the circle notes now. And I need to complete the square twice because I want to get this x group to be a quantity squared, and I want to get this y group to be a quantity squared. So step number 1, we're going to kick that constant over to the other side, just like we did with quadratics. So I'm going to do kind of two things here. I'm going to create some space for a C value with the x group. I'm trying to create a C value for the x group. And I'm also trying to create a C value for the y group. And I'm going to kick the constant over. So I'm going to look at the setup here. I want to create a new C value here that when I factor the x group, I get to a quantity squared to make it look like the circle equation. Then I want to create a C value for the y group that does the same thing. And just like we did with this quadratic here, where I took half of b and squared it, we're going to do that same exact thing. So for the x group here, half of 2 is 1. 1 squared is 1. So 1 is the new C value there. Remember, whatever I do to the left side, I also have to do to the right side. So I have to add 1 to both sides. Here, I take half of 4, which is 2, and square it, and I get 4. I can't just add 4 to the left. I also have to add 4 to the right. So I just completed the square twice. I found my C value for the x group. I found my C value for the y group. Once we create the C value, now we're going to factor each group separately. I'm going to factor the x group. This trinomial right here, I'm going to factor it. I want to find what multiplies to 1 and adds up to 2. And that's 1 and 1. If I factor the x group, it would be x plus 1, x plus 1. The way we write that is x plus 1 squared. And so we've gotten to that quantity squared for the x. Same thing for the y group. I want to factor this y trinomial right here. So I find what multiplies to 4 and adds to 4. So that's 2 and 2. So this would be y plus 2 squared. Now on the right side, I just add all that stuff together, and I get 16. So through completing the square twice with the x group and the y group, I've now transformed this gross-looking equation into the circle equation. Then it says sketch the graph. So the center would be at -1, -2. And the radius would be at 4. And then I sketch. It's not going to be perfect, but... So I plot the center at -1, -2. And then I just go 4 in all directions. 4 to the right, 1, 2, I'm just going to wing it. 4 down, 4 left, 4 up. And I draw my pretty little circle. So pretty. Oh, no, it's not. That's okay. But this is the main reason I wanted to keep this lesson in, because this is something you will have to do when you get to pre-cal, Completing the square is a process that comes back up in calculus. So I wanted to make sure we didn't take this one out. We could do number 2. We're not going to do all these examples. Write an equation of the circle. It has a center at 2, -4, and is tangent to the x-axis. The reason I want to do this one is because of what this word tangent means. Tangent, if you think back to geometry, I don't know how much you remember from geometry, but if you have a circle and you have a line that's tangent to that circle, that means you have a line that's only going to touch the circle at one point. Like I would say this line is tangent to that circle. It intersects it at one point. This is actually a big topic in calculus. We talk about tangent lines all the time. So this is something that I wanted to make sure I had in the back of your minds. Well, let's jump into the problem now that we know what tangent means. So I want to draw a little graph here. It says the circle has a center at 2, -4. So I want to plot that center. 2, -4. So that's the center. Then it says the graph is tangent to the x-axis. Tangent to the x-axis. That means when I draw my circle, it's going to look something like this. I don't know exactly what it's going to look like, but I know that it's just going to hit the x-axis and then like curve back down. It's going to look something like that. That's what it means to be tangent to the x-axis. It's not going to go above the x-axis. It's not going to stay below it. The circle is going to hit the x-axis, and that's where it's going to curve back down. Well, the reason that's helpful, when you write the equation of a circle, you need to know 2 things. You need to know the center, which we do, and you need to know the radius. Well, now I can find the radius of this circle. Here's the center. The radius is just whatever that distance is there to the x-axis. So that radius is 4. So then I can write the equation. It's going to be x, and then it's always the opposite of your value. So x minus 2 squared plus y plus 4 squared equals your radius squared. So 16. Number 3 is one that we actually did first semester. We did the same exact type of problem. I'll bring it back because it does involve some distance formula and stuff like that. But write the equation of the circle if the endpoints of the diameter are -7, 12, and 5, -10. Well, if we're writing the equation of a circle, we have to know 2 things. We have to know what's the center and what's the radius. And what I know is I have the circle. You could sketch a graph if you want. I don't know if that's going to be very helpful, but basically you have the circle, and we know a diameter, doesn't matter how you draw it, we know a diameter is at 5, -10, and at -7, 12. So just a visual for what's going to be happening here. We need to find the center. Well, the center is right in the middle of these 2 ordered pairs. So the center is smack dab in the middle. That's the midpoint formula. So our center is going to be the midpoint formula. If you remember the midpoint formula, you add your x's, divide by 2. You add your y's, divide by 2. So for this one, -7 plus 5 divided by 2 is -1. You're really just finding the average of your x's and the average of the y's. 12 minus 10 is 2, divided by 2 is 1. So there's your center. Your radius, you could find one of 2 ways. You could either find the length of the diameter and divide it by 2, or now that you know the center, I think the easier way to do it, just find the distance from the center to one of these 2 endpoints. That way you don't have to worry about dividing at the end. Just do the distance formula between the center and one of these 2 ordered pairs. Doesn't matter. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. You probably thought you were done with these formulas. They never go away. These things never go away. So we are going to do the distance formula between the center, and I'll use 5, -10. All right. So I'm going to subtract my x's and square it. So -1 minus 5 squared, and then 1 minus -10 squared. So this is going to be, let's see, -6 squared is 36. 11 squared is 121. So that's the square root of 157. That's your radius right there. That's what we just found. That's your radius. Well, remember, to write the equation, we only need to know the center and radius. We found them now. We can write the equation. It's going to be x, and then it's going to be plus 1 squared plus y minus 1 squared equals your radius squared. So the reason I didn't put a decimal or anything, if we square this radius, we get 157. And there's our equation. I'm going to do one more. I'm going to skip these two. I want to redo one like example 1, because honestly, the reason I wanted to keep this in is for problems like example 1. So I'm going to have you guys try one, okay? Here's what I want you to do. Forget about example 4 and example 5. I want you to take this equation, I want you to pause it, and I want you to see if you can complete the square twice and turn this equation into the circle equation. Okay, go ahead and pause it and try it. Okay, so I need to complete the square twice. Create the C value, create C value, move the 4 over. So I always like to set my circle stuff up this way. Group the x's, group the y's, move the constant over. Half of 8 is 4. 4 squared is 16. Do not forget, whatever you do to this side, you have to do to the other side. Keep the equation balanced. Half of -6 is -3. Squared is +9. Your C values are always going to be positive. Anytime you square something, it's positive. And then plus 9. The whole reason we do this is to then factor each group to get our quantities squared. So when I factor, I find what multiplies to 16 and adds up to 8. And honestly, it's always just going to be x and then half of your b value squared. It will always turn out that way. You don't actually have to sit here and think what multiplies to c and adds to b. Throughout this process, this number is always going to be half of your b value. Same thing over here. It's going to be y and then -3 squared. And then equals 29. So we just took that equation and made it look like the circle formula, and we'd be able to get our info from there. All right, let me know if you have any questions. We'll talk about parabolas next time, and completing the square shows up again. So, peace.